Hey everyone, it's Anthony, and today we're going to be showing detectron2 from Facebook. So detectron2 is an object detection machine learning package or module that you can easily get up running quickly, and it's going to do something similar to masked RCNN, where it can highlight or mask regions of an input image that have a particular type. You can also draw bounding boxes and making predictions about what's in the actual box. And you can see it over here on the right, just this quick GIF that's showing that gives you an idea of its capabilities. And it turns out that it's quite helpful for getting started with machine learning, just applying something. And so we want to demonstrate using it. So this tutorial, I plan on getting it set up and running. I want to run it on my computer's webcam. However, I'm running Windows 11, and although you technically can get it running on Windows, it's recommended you run it in Linux. So I'm going to set up a simple Flask application on my Windows computer that will let me send images to a Docker container that's running Linux, and then in Linux we'll actually run the Detectron. We'll set up another Flask application there that can show me the outputs, which I can then view on my host Windows machine. So it's quite a bit to cover in one video, but we'll try to go fast. So to get started, they have all this nice stuff over here. But as I said, the first thing that we want to do is first just grab the webcam image and then send it on over to a instance of some type of Linux instance in Docker. So let's get started. First, I'm going to make a folder for the webcam, and then we'll get going. I can see it actually worked as far as capturing the image. So now we just need to make it into a Flask app. So let's do it. Okay, so you can see we're able to grab a frame, put it into a buffer, make a response object, set the headers, and I was only able to get it to send it as an attachment for this request, and that should work out okay. So let's move on to the next part, which is actually setting up Docker and then also setting up the detectron2 within our Linux image in Docker. So first I need to make sure I actually run Docker to get started, and I'm just going to make a new folder and then we'll go from there. Right, so I'm going to want to install Torch. So I'm going to go to Python Torch, and I'm running this on a laptop computer with no GPU. So I want to select the GPU option, and we can see the configurations that we want here. Linux, use pip, and so here we go. This is what we want to run in our Docker container, and you can see I already set up my virtual environment settings the way I want them. So I'm going to install Torch and then install that Detectron. Okay, so you can see that this Docker setup is good to go now. I am going to install the Visual Studio Code tools for letting me run this Docker image and then developing in that Docker image directly, and then that'll let us seem like we're developing in a Linux environment. So let's go ahead and try that. You can see I added the development container tools just by opening the command palette and then running add development container configuration files, and then told to reopen Visual Studio Code in the Docker container. What we have going on now, you can see it up here, of container existing Docker file. So it's building this Docker image based off Sky. It should have all the stuff installed already. And now we can actually start doing some interesting things. Now we're going to start setting up some code to actually the detectron. Alright, so let's go ahead and try it. Okay, so the first thing we want to do is actually get the image from the host machine into this Docker container. So I'm going to write just a quick script which will hopefully have the image, and I'm just going to save it to this images folder. We're going to start with something simple, which is just getting an image like one at a time. Later we can worry about streaming. Just getting the image will be a nice start. So let's try that. Alright, you can see we were able to successfully pull an image from the host. So I'm just using the request library. Because I'm running this in Docker, rather than going to localhost, I have to go to host Docker internal, and then my port number. Because I'm downloading an image, I can just get the content directly and write it to a file. And that's pretty much it. So now that we can get an image, our next task is to actually set up and run the detectron2 code. So let's dive into that. So there's a few resources we have to get started with that. This is back on the GitHub page for detectron2, and that puts the documentation which we've already looked at. And importantly, it also gives us a link to this Colab notebook. In glancing through this, we can kind of get an idea of how to make this work. We're just getting these configurations and then pulling in configurations from this YAML file. And additionally, if we look at the documentation, we can see that we can also merge in command line arguments. So basically what we're going to want to do, the configurations, pull in a configuration file, and then maybe set up a few other things. And then from there, we can actually run our predictions. So the only tricky thing here is just getting the configuration set up. So let's go ahead and do that. Okay, I'm pulling an image from my host just by downloading an image file that I'm obtaining from my webcam. Then I'm running the setup configuration, and it took me a while to get that all set up properly. I just copied and pasted some code from over here. Also had to look up some of the documentation. So I basically just modified this configuration file. Maybe one confusing thing was to make sure I specify the correct path to its base. Something else I had to do is actually download the weights, and I got that wrong a few times, and finally this is the correct setup. And then also, because I'm running on this on my laptop, instead of GPU, change it to CPU in order to set up the configuration properly. And I return the configuration, then I make my predictor, just doing the default predictor. I get an image, which which is just reading my temporary file, and make my prediction. Then I run the visualization, which is taking in my outputs, my input image, and the configuration all together, and then drawing on top of my image to add the output predictions. And then I'm getting when all that's combined together, I'm calling that image viz. Then I'm just writing it to my temporary output file, which I have to find right here. And then you can see this is my input image, and then this is the prediction of what it actually is. So you can see it's correctly predicted that I'm a person. Just impressive. And there's a chair right here, and there's a chair right here. Not sure what's going on up here. You can see it's predicting there's a computer mouse right here, which is correct actually, and the fact that I got that is kind of amazing. It's very hard to see the detail. Maybe the cord is given. Okay, so the last thing we want to do is to try to combine this with a simple Flask application. So I'm going to take the outputs and put them on a web interface that can stream ideally. I'll see if we can get that all set up. Alright, and there you have it. So let's go over how it works. So there's the Flask app. I'm running this code. It's going to run its main Flask instance. I'm going to run set up the configuration, make my predictor. Then I'm going to, when I go to this URL /s, it's going to route here to the stream function. I'm making a response where I have this generator, and so generator means it can save a state within the function. So rather than just returning something, it's yielding it, and then it'll keep going next time it's called. So that's how it's getting the new image and also making the prediction and showing it. So first, within this loop, it's going to run a prediction wrapper, which is just going to get the image from the host. Then it's going to make the prediction, and then it's going to run the visualization, and it's going to write the image to a buffer, which is basically just going to take the image and put it in the correct format for a JPEG and convert it to bytes. Once I have this byte representation, then I'm going to make this response. So within this snippet called frame, I'm going to say that the content type is an image JPEG, and I'm going to put in the actual bytes and then a new line right here. And the key thing is that my overall response is this multi-part X mixed replace, which means it's going to keep on replacing this everything within this frame. So that's why this actually works. So when I run the code, you can see that it actually works. It's making predictions. So that's a little bit slow. Obviously, if we had a GPU, this might go a lot faster, and I'm sure there's a lot of other things we could possibly do to optimize this. The key thing is, I'm actually running the code in Linux, not in Windows, is the way I have Docker set up. So that's a quick tutorial just showing that I can get my webcam to predictions and bounding boxes and segmentation using detectron2, and I hope that was pretty helpful for you. It was really fun putting it together, and thank you for watching.